Hi everyone, welcome to RPI Data Science. So up to now we have seen meta-analysis of continuous outcomes. So we have seen in the last videos, we have seen on meta-analysis of mean difference and also meta-analysis of means and meta-analysis of also continuous outcomes like correlations. I mean, we have seen mainly continuous outcomes. So for today we will see meta-analysis of binary outcomes. Mainly we will talk about odds ratios and risk ratios, and after that we will start a practical session on mainly how to pull studies that report odds ratios and risk ratios and hazard ratios and so on. So in epidemiology, things are not measured always in continuous. So most of our outcomes are actually binary outcomes. If you take disease, so a disease is usually you have positive, negative, or the presence of a disease or the absence of a disease, or maybe if you take mortality, dead or alive. And many of our epidemiology outcomes, they are categorical binary outcomes, and they follow binomial distribution. And if you take this experimental randomized control trial, so you have a group which is assigned to the experimental group, and there is another group which is assigned to the control group. You can also take this as observational study. So one is on the exposure. Maybe if you think about the cohort studies, so there is an exposure in the side for the and then there is a control group. That means the non-exposed group. And then if you have the number, the disease, so that means these ones, A and C, they are diseased, and then B and D, they are non-diseased. And that's the index, just a sample size in the control group and in the control group and in the experimental group. So one of the measures to decide whether an exposure or an experiment or intervention increase or reduce the risk of some kind of disease, you can measure that association or that risk by using odds ratios or risk ratios or maybe hazard ratios, and also other association measures like risk difference, arcsin difference. There are many other measures in epidemiology. But today we will mainly talk about the risk ratio and odds ratios, and then once we touch a little bit of that, we will continue on pulling the studies together. So if you talk about, I mean, you may have seen in many of the studies I report odds ratios. Odds means it's a probability. I mean, it's not a probability. Odds is not a probability. It's a ratio of event to non-event. So that means a ratio of an event within the same group. Let's say within the experimental group is a ratio of an event to the non-event. So that means disease. The odds of having a disease, given that it's an experimental group, and that means A over B. And then the odds of a disease being in control group means the ratio of number of events in control. I mean, number of events in the control group divided by the number of non-events in the control group, and that means C over D. And that means you get the odds in the experimental group and you get the odds in the control group. And if you take the ratio, and that means you have odds ratio. So in other words, you can divide the odds in the experimental group as A over N in total number. That means NE minus A, because NE minus A is B. And the odds in the control group is C over D, and that means C over NC minus C, because C is the number of the total number of events, minus C is the total number of no events. So that's how you calculate odds ratio. But as I said, odds is not probability. But if you want to calculate probability, that means probability of disease, given that you are in the experimental group, that means you have to divide this with the total number of sample size in the experimental group. So that means A over the total. And that means for the experimental group and for the control group, you have C over the total number of people in the control group. So that will give you the probability of event in the experimental group and the probability of event in the control group. If you take the ratio, that means the ratio of probability of an event in the experimental group divided by the ratio of, the probability of an event in the control group. So that will give you risk ratio. But sometimes, if you are doing meta-analysis, people may report odds ratios. Other times they may report risk ratios depending on their design, and sometimes they may report hazard ratios or something. Let's say you are working on meta-analysis of case control studies, maybe nested case control studies. So some people may report odds ratios and others may report risk ratios. In this case, you may have to convert one estimate on the other. So that means you have conversion. So that means the way you calculate risk ratio from odds ratio is odds ratio divided by 1 minus P. That means this is a prevalence of a disease plus prevalence times odds ratio, and that gives you how to calculate risk ratio from odds ratio. But this comes to the point that is called a rare disease assumption. So that means if the disease is rare, if the disease is rare, so that means prevalence is very low. That means close to 0. So that means 1 minus something close to 0 is almost 1, and then 0 times something close to 0 times odds ratio, and that will give you again 0, and that means 1 minus 0 will cancel out, and that means risk ratio equals odds ratio. So that means a rare disease assumption tells you odds ratio will be an approximate measure of risk ratio. So that's what odds ratio and the relationship between odds ratios and risk ratios. So sometimes if the disease is rare, if you are dealing with rare disease meta-analysis, then you are free to combine risk ratio with odds ratio. But sometimes if the disease is rare, then odds ratio will overestimate risk ratio. So that means, yeah, you have to think about this before you combine this different effect estimators. Last time, if you remember, we have said that. If you remember, I showed you this map, this tree map. So if you are doing a meta-analysis, the meta-gen function from the meta package, we have seen many different functions that are helpful for your meta-analysis. So now we are dealing with binary outcome. For the binary outcome, we use meta-bean for also calculating odds ratios, and also for the risk ratios, we use meta-bean again, the same. But for the others, we have already seen meta-core, meta-mean, and meta-quant. We have already seen that, and we will probably cover again meta-inc, that's meta for incidence rate ratio, and also meta proportion. If you are dealing with prevalence, you can use this. And then also if you are dealing with rates, you can use meta rate. Yeah, but for today, after this session, I will show you how to pull odds ratios either using meta-bean or meta-gen. So these are the main functions that we will utilize in our meta-analysis. And for today, for now, I will close. I will close this session, and I will continue with the next session and how to pull effect sizes using this function. So we will have a practical session in the next one. And until then, see you next time.